Hello everyone, welcome back to my channel. I am Vandana, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Information Science and Engineering, third semester research section. Today in this video, we are going to learn about the subject data structures and applications, particularly about the topic optimal binary search trees. Let's come to the introduction part. An optimal binary search tree is a special tree of binary search tree where the arrangement of nodes minimizes the cost of searching. In data structures, this optimization is achieved by considering the frequency or probability of accessing each key in the binary search tree. The main goal of optimal binary search tree is to reduce the average search time when accessing the keys. What is optimal search tree? An optimal binary search tree is a binary search tree where the cost of searching for a key is minimized based on a known frequency distribution of the key being searched. In other words, an optimal binary search tree is structured in such a way that frequency searched keys are placed closer to the root, minimizing the average search time. Why optimize binary search trees? The concept of optimal binary search trees is important because it aims to minimize the expected search cost when performing operations such as search, insertion, and deletion on the binary search tree. This is especially useful when there is a known frequency distribution of how often a certain keys are accessed or searched for, as it allows the efficient searching by arranging the trees in a way that minimizes the total search cost. Applications of optimal binary search trees. In that first one, minimizing search cost. Search cost refers to the number of comparisons or steps required to find a particular key in the tree. In a regular binary search tree, the search cost can vary depending on the key's position in the tree, with some keys requiring more comparisons than others. An optimal binary search tree is structured to minimize the total search cost, where more frequently accessed keys are placed closer to the root, reducing the number of comparisons needed to access them. This is particularly important in systems that perform frequent lookups. And the second one is frequency of access. In many real world applications, certain keys are accessed more frequently than others. If these frequently accessed keys are placed closer to the root of the tree becomes more efficient. For example, in dictionary or database, some words or value might be queried much more often than others. By constructing an optimal binary search tree, those frequently queried items are closer to the root, optimizing the lookup time. And third one is efficient memory usage. In case where large amount of data are stored in binary search trees, optimizing this structure can improve overall system performance, especially in terms of the time complexity. Accessing keys in optimal binary search tree is faster, which leads to more efficient use of memory and processing power, reducing the overall resource load. And the fourth one, improved performance in search operations. In a typical binary search tree, the performance of search operations like finding, inserting, or deleting a node can be inefficient if the tree is unbalanced. An optimal binary search tree ensures a balanced structure in terms of the frequencies of access, leading to better overall performance for searches. And the fifth one is real world applications, databases, and indexing. Optimal binary search trees are useful in databases where certain records are accessed much more frequently than others. An optimal binary search tree allows for faster queries times for frequently accessed records. Compilers. When generating efficient code for searching or evaluating expressions, an optimal binary search tree can be used to optimize the performance of search operations. File system. In systems that organize files in hierarchical tree structure, optimal binary search trees can optimize file retrieval times based on how often files are accessed. And the sixth one is cost effective in terms of operations. By minimizing the search cost, optimal binary search trees lead to fair operations for each search, improving the overall time complexity. For instance, if the cost of searching of a key is proportional to its depth in the tree, an optimal binary search tree minimizes the number of cost comparisons needed, leading to faster searches. Seventh one, balanced trade-off. An optimal binary search tree represents a balance between the search cost and the distribution of keys. If no optimal search is sought, a binary search tree could end up being skewed. Example, a linked list. In the worst case, resulting in poor search performance, optimal binary search tree ensure that the tree structure is balanced on a way that minimizes access time while considering the frequency of each key. Algorithm for optimal binary search tree initialization, compute weights and cost for single keys and dummy keys, iterative computation, use a bottom-up approach to compute optimal cost and determine subtree roots. Tree construction, using the root matrix, build the optimal binary search tree. Finally come to the conclusion. In conclusion, optimal binary search trees are specialized from a binary search trees designed to minimize the expected search cost based on the frequency of key access. By arranging keys with higher access frequencies closer to the root, and optimal binary search tree reduce the number of comparisons needed to find frequently accessed keys, leading to improved search performances. The tree structure is typically constructed using dynamic programming, ensuring that both the tree and its subtrees are optimally arranged for minimal cost. However, constructing an optimal binary search tree requires careful consideration of the frequency distribution, and it's typically more computationally expensive than a standard binary search tree. Despite this, the benefits of minimizing search tree makes optimal binary search tree highly valuable in scenarios where search efficiency is crucial. Ultimately, optimal binary search trees are powerful tool for optimizing search operations in systems where key access patterns are well understood. Thank you for watching this video.